23rd? It's on the Wednesday. Huh? It's May 23rd Wednesday at this time, you know. Alrighty, folks. So these are all some of the official things I wanted to let you know. Now, getting on to this, the catabolism of the fats and the proteins, because I'm going to talk about the peptones in the microbial growth, how the peptones are utilized and what happened with the bacteria are trying to degrade some of the fats. Most of the fats are the triglyceride with a glycerol backbone or with a glycerol, and you have these chains of carbon atom which are the fatty acid chain attached to this glycerol backbone. Anytime the fats are to be utilized as an energy source, those fatty acids need to be cleaved off from the glycerol backbone. So there is an enzyme called as lipase. It breaks down this bond, the phosphodiester, not the phosphor, but the ester bond between the glycerol and the fatty acid. That is broken down to release the glycerol and the fatty acids. The glycerol part, it goes into the intermediates of the glycolysis. It basically gets into the glycolytic pathway, the glycerol path, the glycerol backbone of the fatty, of the lipids. But the fatty acids, what they do is, these fatty acids, they undergo what is called as a beta oxidation. It undergoes beta oxidation, and what happens, each of those fatty acids, this is what is called as a beta oxidation. Each of these fatty acids which have been there in a set of 2 carbon, just 2 carbon, then another 2 carbon, then another 2 carbon, 2 carbon, they go as acetyl coenzyme A into the Krebs cycle. And that's why on a molecule to molecule basis, 1 gram of fat, on a weight to weight basis, 1 gram of fat provides a lot of energy because the fatty acids which are released, they undergo beta oxidation or with 2 carbon atoms at a time. So those fatty acids will be shorted by 2 of the carbon atom, and then the acetyl coenzyme A is generated, and this acetyl coenzyme A will be directly channelized into the fat, into the Krebs cycle. And that's why I say on a molecule to molecule basis, fatty acids or fats gives a lot more energy compared to glucose as such. So this here it shows it is shorter by 2 carbon atom, then another 2 carbon atom, 2 carbon atoms. So subsequently all the carbon atoms will be used up in the fatty acid oxidation.
And each pair of carbon become acetyl-CoA?
Yeah, what happened for each, and that's why it is called as beta oxidation, because this is the alpha carbon, this is the alpha, this is the beta, and between the alpha and the beta carbon, it gets cleaved. A coenzyme A molecule gets added up to it to form acetyl coenzyme A. And that acetyl coenzyme A is directly, it goes or it merges with the Krebs cycle intermediates. Alrighty, folks? So that's the reason why fats per se gives a lot more energy, because you have a lot of carbon atom of the fatty acids to produce energy. Okay, and once it goes into the Krebs cycle, remember FADH2 is generated, some amount of ATP is generated by substrate level phosphorylation. So overall, you get a lot more energy. And at the same time, during the oxidation, what happened? FAD is again reduced to FADH2, NAD is reduced to NADH, and these are directly picked up, or they're directly channelized into the electron transport chain. So overall, this is a very efficient process for the bacteria to obtain energy by the oxidation of fats. For the proteins cannot be used as such, like it needs to be hydrolyzed. And I'm going to give you the concept of peptone because I talked about it. The protein need to be broken down into smaller pieces or the peptones for better utilization by bacteria because bacteria always absorbs the nutrient. We talked about it earlier in the beginning. Bacteria does not photosynthesize except for the photosynthetic bacteria. They do not ingest, but then they absorb the nutrients. So if they are growing in or if they have been supplemented with just the proteins or the peptones, which are short sequences of protein, first of all, there will be hydrolysis of the amino acids of the peptones, and the individual amino acid will be made free. So there will be hydrolysis, individual amino acid will be made free, just like in the case of the lipids, action of lipids and water, the glycerol molecule is separated from the fatty acid. Here, the peptide bond will be hydrolyzed and individual amino acid will be made free. Those amino acids, once they are made free and they are picked up inside the cell, this amine group of the amino acid needs to be released free before the carbon skeletal can be used up. And that process, when the amine group is made free as ammonia, this process is called as deamination. This process, when the ammonia gets released from the amine group of the amino acid, this process is called as the deamination. And following deamination, the carbon skeleton which is left out, that carbon skeleton goes into the Krebs cycle. This goes into the Krebs cycle intermediate. This is one of the Krebs cycle intermediate, and it goes or is channelized into the Krebs cycle. So these are the main two things about how proteins and how the lipids, they are metabolized by the bacterial cell. And with this, it completes this chapter, and we are going to move on to a new chapter now, which is all